Assalamualaikum and good day everyone. We are from Group 1. My name is Daniel Iskandar and other members is Azim Akif, Muhammad Zuhairi, Ain Nur Fitriani and Nur Anisa. We will discuss about 5 topics in this presentation and its subtopic. First one is introduction and the subtopic is problem background, objective of the study, assumptions and scope of study. Second one is background, and under it we have company background, model conceptualization, and activity cycle diagram. The third, we have data collection, which is we have process, time observation, analysis, distributions, parameter distribution, and goodness of fit test. The fourth is model translation, and we have description, simulate, setting involve, verification, and validation. And the last one, we have results analysis, which is we have observation, simulate, description results, and experimentation results. Under chapter 1 is introduction of study, we have a problem background, which is the company has started in 2009 with only 2 units of hydraulic washer, and in 2011 the company added 3 more hydraulic washer, and still the weekend we have a long queuing time. So the objective of the study is to reduce the customer queuing time by adding more hydraulic washer. The assumption of this study is to reduce the queuing time, and the scope of study is to focus on the relationship between the number of hydraulic washer units and queuing time. In this chapter, we will discuss about company's background, model conceptualization, and activity cycle diagram. The first thing is company background. The company is a startup business in 2009 and it's located in Bandung, Indonesia. It's operate actually from 8 a.m. until 6 p.m. and it offers service such as cleaning exterior and interior of car, including drying the car. The model conceptualization of this is we have the entity, which is customer car, and the state is arrive, queue, wash and dry, queue, and complete. And the second one is hydraulic washer unit. We have idle, wash, and idle. And the third one is drying machine. We have idle, dry, and idle. In this activity cycle diagram, when the first customer arrive, they need to queue first and go to the washing machine, then need to queue and then go to the dryer, and then they need to queue, and the cycle is complete. In this chapter, we have a process which is search for secondary data from article, then the time observation, which is Saturday, 8 a.m. until 6 p.m. And the analysis is we received the largest number of customer, which is 63 customers, and the distribution is exponential and normal. And goodness of fit test, we choose chi-squared. For process of the data, we have 5 steps, which is we need to clarify the data, then we need to know the type of the data. Then after that, we need to collect and record, then also to organize the data. And the final one, we need to analyze the data. For time observation, we have two, which is day and the time observation. The date we choose is 9 July 2011, which is Saturday, and the time is 8 a.m. until 6 p.m. By organizing and record the data, we need to analyze the data, which is we have here the number of customer and the entire arrival time, washing time, drying time, and waiting time. We can see here we have a 63 customer. This is the result for the distribution and parameters distribution for inter arrival time. And this is the distribution and parameters distribution for service time for washing customer vehicle. And the last one, we have a service time for drying customer vehicles. For goodness of fit test, we chose easy fit to get the output. Then, based on the chi-square test, we know that the test statistic is 3.7177, which is less than a critical value. Hence, we fail to reject the H0 at alpha equals to 0.01. And the probability density function, which is given here. And next, we see that the goodness of fit test, which is every time pushing customer vehicle, and we know that here the chi-square test, which is the test statistic 3.6236, is less than the critical value, hence fail to reject the hash note at alpha 0.01. And we can see here the probability density function. And the last one is service time for drying customer vehicle, which is we can see here chi-square test for test statistic. We have 4.3143, which is less than a critical value, hence fail to reject hash note at alpha 0.01. Then also we can see here the probability density function. And I think that's all for this chapter. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Azim Hakim Fidaus and I will continue the group presentation. So as stated by Daniel in the previous slide, our data is following the data obtained from the research paper that we look into. So here I will try to conclude what the data interpreted as. So for the starting point, by the arrival rate of the data, when we feed the data by using easy feed data, and the data itself follows an exponential distribution with the mean of 0.1095. From the research paper, it stated that the data actually they follow the routing out by priority from machine 1 until machine 5. Next, for queuing for machine, we know that the capacity is equal to 1 since we want to minimize the queuing for each of the machine. Hence, the minimum waiting time is also from the data that we obtain, which is 4, 3, 10, 2, and 2 for machine 1 until machine 5. For washing activity, we know that when we feed the data, we know that they follow a normal distribution with mean 2.26.032 with the standard deviation of 9.2247. Since all of the machines are identical, hence the distribution are all the same for machine 1 until machine 5. For queuing drying, we know that the capacity is 7 by the research paper itself because they set it by 7. Hence, the minimum waiting time is also stated with 3 minutes. Lastly, with the drying activity, the drying also now follows a normal distribution with mean of 19.467 with the standard deviation of 12.943. So after obtaining the data, we try to put it into a simulation mode by using Simulate. So the data will look like this. This is the starting point. This is the queuing. This is the activity for the washing for machine 1 to machine 5. This is the queuing for the washing, and this is the queuing. This is the drying activity. When try to run that simulation, we see that the data follows like this. The arrival of the customers is 133 and the finished product is 108. This shows that the data itself actually accurate since for the customer, they want to limit them with only 100 customers per day. Hence, I would say that this is the representation of the problem that we obtain. Here, I will explain to you about chapter 5. So from chapter 4, shown previous one, we have the results whereby the simulation that we used before follows the problem that we obtained. Here to improvise, we want to reduce the queuing for Saturday. Since Saturday, the customer came very big numbers. So here, how do we improvise is by adding one more washing machine in the system here. This is because we know that the queuing system is actually late due to the minimum number of the of the washing machine. Because here we know that for the drying part, the replication is 7, which means that the drying process, we can say that it has 7 machines. So to improvise the number of queuing, here we add up the number of washing machine so that the customers can be served appropriately with the number of the drying activity. So after running this simulation, here we obtain that, as you see here, the number of arrival rate is increased from previous one, and also the number of completed job is also increased from the previous one. Here that we can conclude that by adding the washing machine one more to the system, we can serve more customers. Hence, by serving more customers, we can reduce the number of queuing for the day.